Hello everyone. Today we'll be learning about clustering in data science. Clustering is a powerful technique for uncovering hidden patterns in data by grouping similar objects together. Basically, in clustering, we groups objects which are similar to each other so that we can easily identify and use them in our process of data science. It's a key tool in machine learning with a vast array of applications, and further we are looking its application is implementations, k-mean algorithms using Python. Let's see what is clustering algorithms. So we have k-mean algorithm. The k-means is an iterative algorithm that partitions data points into clusters based on their distance to cluster centroids. Basically, there are centroids, various centroids, and the distance from those clusters defined by an algorithm called k-means. How it works, it starts by randomly initializing k centroids. We initialize k centroids randomly, assigning them values points nearest to the centroid, recalculates centroids, and repeats until whole coverage. Now, what is the implementation of k-mean? We implement k-means using Python or R. Basically, here we are looking for Python only. Skikit learns k-means class offers a flexible and customizable approach to k-means. It provides a powerful and efficient implementation with various options for initialization methods. We will look in the IDE how these methods work and how to import all the packages that are needed. And you can access the cluster label using the label attributes and the cluster centers using the cluster underscore center attributes. Uh, these concise syntax makes the implementing and experimenting with k-means in Python straightforward and efficient for various datasets and parameter configurations. K-mean cluster algorithms are very easy to implement through Python as it is an easy language. Further exploration of parameters such as max underscore ITR, toll, and n underscore in it allows for fine tuning the algorithm's performance and con- uh, convergence behavior. Now, let's see what are different evaluation metrics that we use to evaluate clusters. Silhouette score is one of the crucial metrics, measures how well each point fits within its cluster compared to other clusters. How the cluster is compared with each other. This is signified by silhouette score. Davis Bulletin Index. Basically, these are the names of the scientists or data scientists who gave these relations between the clusters. For evaluating the matrices, Davis Bulletin Index is one of the most crucial evaluation metrics. It evaluates the ratio of within cluster distance to between cluster distance. Kalinski-Haraban's index is another matrix to evaluate cluster, measures the ratio between cluster variance to within variance clusters. Now moving forward are some real world applications and insights of clusters. Real world applications of clusters includes customer segmentation. Clusters are basically used for customer segmentation. As we know, clustering is a method in which we group similar objects together. So divide customers into based groups based on their buying behavior for targeted marketing. Many companies do this type of clustering for suggesting products that are related to a specific group so that consumers can buy the products according to their groups. Image recognition group similar images for image search and retrieval. Uh, Image recognitions helps AI and artificial machine learnings to group similar image together for better output generation. Anomaly detection identify outliers in data for fraud detection or system monitoring. Clustering similar type of data in a way reduces the chance of outliers as they exclude outliers and group similar type of data. Now Let's look at the code of clustering process in Python. As you can see here in my VS Code IDE, I have imported packages like panda aspd, import numpy as np, imported matplotlib, and sklearn.cluster. This is the library that you have to import for the clustering. sklearn.datasets. Now, how to generate synthetic data for clustering. We are assigning x and y equals to make underscore b blocks and then passing the parameter ensample centers and random states. We are taking 4 centers here. First method is to apply k-mean clustering. To apply k-mean clustering, we use k-means equals to k-means, and in the parameter we are passing the clusters. There are 4 clusters and we have selected 4 centers and random state to 42. Then calling the function by k-means.fit. How to predict the cluster labels? Here we simply write labels equals to k-means.predict and then predict the cluster labels. How to visualize the cluster? Plot.figure passing the figure size in the parameter as parameter. Plot.scatter passing the parameters like c map, etc. Plot.scatter again passing the parameters like k-means.clusters and centers. Plotting the title label and then showing function with plot.legend and plot.show. How to print the cluster? Simply use the print function and print the desired output and print the label assigned to the each data point using the print function labels for each data point. Hope you have understood this topic of clustering. We'll meet in the next video. Thank you.